In this video, I will talk about a very rare and trending way of using gasifiers, as well as a subject very profitable and hidden for the average person, that is, about direct reduction of iron by generator gas. A brief description to understand the picture. It is no secret that there are fundamental commodities on which all human civilization rests: oil, gas, coal, steel, and others. The existence and development of civilization as we know it today are impossible without them. This makes such commodities extremely merchantable and constantly increasing in price. For example, global steel production is only going to increase, and the price of steel is going up. Global steel production has doubled in the previous 15 years. Steel is smelted with expensive coking coals, electricity, and gas. Naturally, prices rise every day, and the non-renewability of energy commodities makes the price of steel higher and higher every year. I want to talk about an extremely closed subject, in which very few players are active, and which, like a carrier rocket, throws its owner upward financially, like all the famous oligarchs who somehow took possession of the metallurgical enterprises, and now Forbes writes about them. Direct reduction iron is used exclusively in electrometallurgy as a raw material in steel production. It is a direct and very serious competitor to scrap metal and cast iron. And in metallurgical literature, this method is considered to be one of the most promising directions of effective development of world metallurgy. Why? It is known that the use of iron reduced in this way during steel melting in electric arc furnaces allows to produce the highest quality, cleanest metal without harmful impurities, suitable for use not only in standard industries but also in high-tech. I liaised with a man dealing with this closed subject for a certain period. He focused on extracting precious metals from mine rocks and slimes. While others passed by the waste heaps, he analyzed their composition. For example, one day he stumbled upon a useless waste heap, which, according to his analysis, had a high gold content. He immediately bought and recycled it, making a fortune. In the process of our communication, he bought one of the sludge pits, from where he started to extract valuable metals. As for direct reduction of iron, we tried to create a program for the reduction of fine iron oxide with generator gas. But neither he nor I understood the relevant technology at that time. All he was able to find was a place near Krivy Rig where iron oxide came in wagons to be processed and came out a finished product after reduction. Somehow he managed to negotiate and found out that it was a furnace operating as a tunnel brick kiln, where pots of metal were driven on carriages and fired in a gas environment. No one was allowed in, not even to look at the facility. The subject was quite closed and profitable. In the end, my acquaintance left for the sludge pit he bought, and everything remained at the level of words. And so yesterday, digging out something interesting from my channel, I came across an article about how this subject was dealt with in the West. A fluidized bed gasifier was in fact used to directly reduce iron there. I decided to make a video about this article, which I present to the public. And this video is also an attempt to find interested persons who would like to work on this matter. A little more about the process itself and then about the facility described in the article. Direct reduction of iron is its reduction from iron ore or pellets using hydrogen and carbon monoxide, essentially generator gas, or ammonia and solid carbon. The process itself takes place at a temperature of 1000 degrees. Such terms as metallization, partial metallization of ores, direct production of iron, direct reduction iron metallurgy, and coke-free iron metallurgy are also used in reference literature. The product of the process is called direct reduced iron. Attempts to obtain steel bypassing the blast furnace process were made in the USSR back in the 1950s. Industrial production of iron directly from ore, bypassing the blast furnace process, using coke, appeared in the 1970s. The first direct reduction plants were low efficient, and the final product had relatively many impurities. The process began to spread in the 1980s when large-scale natural gas began to be widely used in the mining and metals sector. The gas was ideal for the direct reduction of iron ore. In addition to natural gas, it was possible to use gasification products of coals, in particular lignite, associated gas from oil production, and other fuels acting as reducing agents in the direct reduction of iron. Technological changes in the 1990s made it possible to significantly reduce the capital and energy consumption of various direct iron reduction processes, resulting in a new leap in outputs of direct reduction of iron. Now, while making this video, I managed to find analogs of this technology in world practice. These are Midrex and Phoenix companies. What happens is that iron ore fines, which make up 80% of the total amount of iron ore, must go through a preparation stage, i.e. the process of pelletizing and sintering, in the blast furnace process. On the contrary, fine iron ore can be directly loaded into the reduction process when using fluidized bed technology. This method produces iron of the same quality as traditional blast furnaces but avoids coking and sintering of fine-grained ore. The loaded iron ore passes through fluidized bed reactors where it is heated and reduced to direct reduction iron. Then it is loaded into the smelter gasifier, where the final reduction and smelting take place. Generator gas is produced in coal-fired gasifiers by feeding them with oxygen. Another advantage of the process is the waste combustible gas, which can be used for heating in a steel mill or to generate electricity. For those who are interested in this topic, my contacts are below the video.